Today we will focus on one of the disciplines that was extremely precious for Roger Bacon, namely on optics or perspectiva. And our special guest will be Nader El-Bizri, who is a professor at American University of Beirut, currently a visiting scholar at Durham University. He published extensively on Arabic philosophy and sciences, but also on phenomenology. And today he will talk about Alhazen's influence on the introductory parts of Roger Bacon's perspective, or the fifth part of Opus Maius. Just the last thing before the lecture, if you will have any question, please just send me a message by means in the chat. Just a word, a question or follow-up, and just to make me sure that I will not miss any words in hand. So, Nader El-Bizri, the board is yours.
Well, thank you very much for your kind introduction and also for the invitation to deliver this presentation as part of your series. It's lovely also for me to meet old friends through this session, and it's good to know that you are all well, and also to meet new faces, hopefully new friends on the long run. The presentation will be focused on some kind of moving between Roger Bacon and Alhazen around certain highlights from part 5 of the Opus Maius on perspectiva. Given that the full extent of that part cannot be covered in one session. It's very intricate in terms of the technicalities that it brings forward, and also in terms of the nuances that distinguish the approach that Bacon undertakes when compared with the sources that he's looking at, and particularly in this case, the source being the optics of Ibn al-Haytham. I must say that my presentation comes under a series of also other accompanying activities that have been undertaking since January under the Leverhulme visiting professorship at Durham University. And I've been looking at different angles through which we could approach the optics of Ibn al-Haytham, and trying to also offer perspectives on this from a variety of disciplines. So angles that focus more on the mathematical aspects of the work in the advanced sciences of mathematics and physics in Durham. That's part of the lectures I offered in this regard. And I'm grateful to you for offering me this occasion to bring to the fore some elements of Ibn al-Haytham's optics in relationship to your reading of the Opus Maius. I will start by sharing slides that could prompt a bit certain aspects of the highlights that I will focus on in terms of my reading of the part 5 of the Opus Maius, while also trying to link it to some aspects of the theories of direct vision that we find in the optics of Ibn al-Haytham. So I'll start first by sharing the slide, which I hope will appear with clarity. We tested it earlier, so I hope it is fine. I will start a bit by highlighting that reading the part 5 from the Opus Maius already indicates to us a different orientation in terms of treating the questions that pertain to theories of vision and light, in terms of the sequence of thematic approaches to these theories that we find in the text of Bacon, which are different in the ordering from what we find in the optics of Ibn al-Haytham. So, for instance, we see ourselves starting in the perspectiva of Bacon from the part that Ibn al-Haytham begins to discuss elements of it in his book 2 of the Optics. And I started with this suggestive image that is trying to draw on the tradition of Ibn al-Haytham and of Bacon as part of a synthesis in optics that we find in the book of François d'Aiguillon, an architect and a Jesuit mathematician, the Opticorum Libri Sex. And this is a illustration by Rubens of the study of the anatomical structure of the eye as we see it here being dissected, and more importantly, a feature that we will encounter from the start with Roger Bacon in terms of his approach to the theory of direct vision, the pointing to the placement where we find the common sense, which is in the anterior part of the brain. And this is the same location that Ibn al-Haytham evokes in his consideration of the last sentient organ, which is, according to him, also located in the frontal part of the brain. Now, if we move to the discussion, as I said, the organization of the two texts differ in terms of the engagement that we find with the Opus maius directly with what is termed as 29 visible properties or visible intentions, which correspond to the treatment of these visible properties in the optics of Ibn al-Haytham with book 2. Now, Ibn al-Haytham enumerates them as 22 visible properties, or we could even call them visible intentions, namely in saying that we detect in the visible object certain meanings, certain attributes that we list under terms such as the distance, position, shape, size, even evoking aspects that pertain to beauty, to ugliness, opacity. And these visible properties are enumerated by Ibn al-Haytham as being 22, while we find them with in the Opus maius as indicated as being 29. Even though when we look at other manuscripts from the optics of Ibn al-Haytham, we have sometimes suggestions in these copies, other than the ones that were upon which were Sabra based himself in establishing the text, we have them enumerated as 26 visible properties. Now, the term that is used for them in the optics of Ibn al-Haytham is ma'ani mubsara. And here there is a focus on the intention or the meaning behind what is being seen, and therefore already indicating that sight itself, vision, and in particular direct vision, does not occur simply by way of the introduction into the eye of rays of light and of color as they propagate in a rectilinear fashion in the ambient environment between the eyes and the object of vision. And that ambient environment should have the property of being isotropic, homogeneous, and having a sort of continuous level of its density as a transparent medium. And these rays of light are propagated in a rectilinear fashion within this homogeneous transparent medium and are introduced into the eye. Now, with the Opus maius, and particularly the selections that we opted for in terms of just getting some highlights from the text for this session, we see a direct involvement with the cognitive aspects of vision by way of evoking the role that is undertaken through the common sense and how it relates to other functions of the faculties of the mind, in particular a focus on imagination, and then the evocation of this notion of fantasia and of the memorative faculty. And we find with Bacon also an introduction of the estimative faculty, which he derives from Avicenna, as he himself indicates, the faculty of wahm. And this splinters the senses into two main classes. One class which has to do with what is coming out from the external environment in terms of sensory experience that is gathered in the common sense, which is seen as a organ in the anterior part of the brain. And there is another class of senses that is inner and that pertains to aspects of judgment in perception, and particularly in relationship to the estimative faculty, in the manner it detects in the object of vision or in entities that are visible in the external environment. It detects in them certain meanings, meanings that can evoke in it a particular relationship with the entity that is derived by way of a cognitive process rather than detecting it as a visible property in the entity, like a visible property of its size, a visible property of its shape, a visible property of its opacity, a visible property of its distance, its position, which can be somehow situated in the external environment independently of how that entity impinges on the faculties in terms of evoking meanings that can perhaps lead to something akin to an aesthetic experience or an experience of fearing what is being witnessed. And that estimative faculty that Bacon is focusing on is not just found in the human being, but can be found also in the manner certain animals react to danger, and therefore they see in certain circumstances that which could cause fear in them and therefore lead them to flee the scene. Now, Bacon is discussing these in the context first of evoking these aspects of cognition that are involved in the workings of the common sense, of the imagination, of the memorative faculty and the estimative faculty. We see something similar in the tradition of Ibn al-Haytham, but the level of tying these faculties to specific locations in the brain is not indicated in the optics of Ibn al-Haytham. Ibn al-Haytham rather states that the last sentient that is in the anterior part of the brain is the one that indicates to us the termination of a neurological, physiological process of vision that starts with the crystalline lens and ends in the last sentient in terms of the transmission of the impress or sensation that is coming from the visible form, which comes through physical rays of light and physical introduction of color into the eye that causes a sensation that is felt by the last sentient. But he doesn't go further into indicating where we can locate the imagination or memory or discernment or judgment, what he calls مخيلة, ذكر أو ذاكرة أو حافظة and التمييز والقياس. So Ibn al-Haytham evokes a notion of qiyas in the sense of a almost syllogism that takes place when we are looking at things in terms of deriving certain intentions out of what we are looking at. But this becomes a psychology of vision, a philosophy of mind that is rooted in the brain, but without the effort to locate these faculties in specific parts of the brain. Like we find an attempt to locate these faculties in parts of the brain on the part of Bacon. So that's an additional distinction in terms of the way they both approach these questions pertaining to the cognitive faculties that involve that interplay between common sense, imagination, memory, estimation. And in the case of Ibn al-Haytham, it is imagination, memory, recognition based on prior knowledge, discernment, and analogical kind of comparative measure, or some form of also syllogism. Therefore, evoking the role of language, the role of a logical process through which we come to recognize what we are seeing. Now, there is a distinction that is done in the context of Ibn al-Haytham's approach to the study of this physiological, neurological aspect that underpins the psychology of vision. Like it is the case later with Bacon, it is mediated evidently via a study that is based on the anatomy of the eyes, but goes even beyond that into evoking anatomical features that relate to the optic nerves, the common optic nerve, and then even considerations of the frontal part of the brain. But in the case of Ibn Haytham, to come to that level of investigation that evokes the physiology, qua also neurology of vision and the psychology of vision, he has to also focus on the manner this occurs by way of the introduction of rays of light and of colors into the eyes from the ambient environment, as these rays of light and colors are emitted from lit, visible objects that are facing the eyes. So that's the starting point with Ibn al-Haytham, is that the investigation starts first with the consideration of the properties of the propagation of rays of light and of color in a single transparent, homogeneous environment, in such a way that these rays of light and colors propagate rectilinearly, and that they are emitted from every point on the surface that is lit and eventually visible of the object of vision. So it is a sort of a spherical irradiation in all directions of rays of light that propagate in a rectilinear fashion. Now, this becomes the basis for eventually starting to look into the structure of the eye in two modes of analyzing it. So the eye is analyzed at first in terms of its anatomy, like we find it in the case of Bacon. Bacon starts from a different approach than that of Ibn al-Haytham, because he is starting with the sort of physiological and psychological aspects of vision. His starting point starts from the brain outwards in terms of considering the manner the optic nerve is passing through the aperture within the bone cavity that houses the eye, and goes further into analyzing the various membranes or coats of the eye, and focuses, for instance, on the crystalline and the vitreous, again as a one organ that has two parts to it. So the direction of the analysis comes with the Bacon from the brain out into the eye itself, while with Ibn al-Haytham, because the starting point in the treatment of the topic starts with the rays of light and color coming onto the eye, the starting point becomes more from the standpoint of considering the various transparent coats of the eye until he reaches the crystalline, and he describes it as a lens. He uses the term lentil, almost like a atsa, and he describes its geometric structure. But then, while he's talking about all of these coats that are transparent of the eye, so starting from the cornea to the uvea and the albuginous humor, he reaches the crystalline. But when he stops at the crystalline itself, he describes it also as a sort of sensing organ. So it is not only acting as a lens, as a sort of instruments of the refraction of light, but also as a sensing organ. And that sensation itself is felt within the vitreous humor and reaches the optic nerve, which is described by him as constituted of small filaments. While we see in Bacon a sort of direction where the optic nerve is itself thought of as being filled of the same stuff as the vitreous humor that constitutes the posterior part of the whole organ that groups the crystalline or glacial humor with the vitreous one. Now, if we move further into the discussion just of the features of how particularly the crystalline and vitreous themselves allow for the introduction of the rays of light within the eye, and how these rays of light are propagating once they enter through the various coats, transparent coats of the eye. So for instance, first, before we look at more closely at what happens at the level of the crystalline and the vitreous, let us consider a sort of a broader diagram for the manner light is propagated from a certain visible lit surface. So let us take it just by way of approximation or abstraction as constituted of these 2 points, A and B, or what lies between them. Now, from point A, let's say we have the spherical irradiation that is going in every direction of rays of light that are emitted from this surface that is not self-luminous. We're considering here the general conditions of looking at objects of vision rather than looking at self-luminous entities. So we're not looking here at, for instance, the fire itself or looking at the sun. We're just looking at a surface in a given space that is in front of the eyes and itself is lit by a self-luminous entity or lit by an environment that is lit by a self-luminous entity. And this is the kind of level of engagement of experimentation that we find in the optics of Ibn al-Haytham, which in the Opus maius is pushed to a different part of the text rather than being entwined in the same way we find it in the context of the optics of Ibn al-Haytham. So let us consider the fact that we have multiple rays coming from A, multiple coming from B. The ones that count in terms of what is to be considered as part of direct vision and the conditions that need to obtain in a geometric optics context. And here, when we say geometric optics, we're saying it in the sense of the manner Ibn al-Haytham has combined the mathematics with physics, and therefore trying to give an explanation of the intromission theory of vision through some form of a mathematical modeling. From A and from B, only those that are orthogonal to the spherical outer surface of the eye that count for direct vision. And these, because of being orthogonals, therefore falling at a perpendicular onto the surface, they follow the properties that relate to the refraction of light as it passes from a given transparent medium into another, in this case from air into the transparent membranes, outer membranes of the eye, which have more density. So it's passing from a less dense transparent medium into a more dense transparent medium. Because they are orthogonals, they continue through all in a direct way. So without refracting, without diverging. So they continue rectilinear in a rectilinear fashion in the manner they have been emitted in the ambient transparent environment that is between the visible object and the eye. Now, what is of concern in this case, in the case of Ibn al-Haytham, is how the image of AB as a surface is obtained as a sort of impress, almost point by point correspondence between the points that are on the outer surface of the visible object that are opposing the eye and the points that correspond to them in a sort of a geometric abstraction on the outer surface of the eye. So we have a sort of a image or an impress that is along this line AB. Now, if we look at what happens further within the eye itself, now these rays of light are coming at orthogonals. So these are the ones that are continuing in a rectilinear fashion, passing through all the transparent coats of the eye until they also pass through the outer surface of the crystalline. And the outer surface of the crystalline will have the center of the eye as its center also. So as if all of these rays of light that are coming in an orthogonal manner are going to converge in the center of the eye. But what happens is that as they pass through, when they hit the posterior spherical section of the crystalline that has a different sort of radius in terms of the manner its curvature happens, and it is opposing to the direction of the center of the anterior surface of the crystalline, the light rays refract. And this indicates that the image that we have of a given object, let's say AB, does not get inverted. Because if there is no refraction here, and these orthogonals continue along these lines, then there is an inversion of the image. While what happens is that there is no inversion of the image, it is maintained, and the focus continues to the back of the vitreous, which touches what would, in the language that is used by Bacon, not by Ibn al-Haytham, would touch the retina. Now, this preserves, therefore, the spatial ordering of the object of vision in the manner it is having an image of it transmitted physically by way of the impress of these rays of light that are physical sensations that are felt by the crystalline humor within the crystalline lens. It is a sensing organ. And Ibn al-Haytham describes that sensation that it could be like touch, but also it could be akin to pain. And why it is closer to talking about it in the sense of pain? Because he tells us that when we look at a intensely lit surface, or in more sharp manners, if you look, for instance, at the sun, there is a sort of severe strain on the eyes that amounts to something akin to pain. So now the crystalline is not only an optical instrument, it is a sensing organ. And the sensation of these rays of light is carried through the vitreous to reach the optic nerve. And from each of these eyes, these sensations come to the common nerve, and then they split again and are gathered into the last sentient, what is being carved out in this artistic illustration. Now, beyond the last sentient, as I said, in the case of Ibn al-Haytham, there is a talk about a psychology of vision and evoking of the faculties. They are part of brain phenomena, but he doesn't go into the detail or speculation or conjecture as to where memory is located, where fantasia is located, where judgment is located, where discernment is located. So that's a distinction from what we find in the attempts that Bacon undertakes based on, as he evokes it, on Ibn Sina or Avicenna from one side, and Constantinos as he mentions him more specifically in relationship to the anatomy of the eye. Now we have diagrams in the Opus maius that describe also this process of the refraction in the crystalline lens, which is also a sensing organ, but here he uses it as a sort of biconvex. So it doesn't have exactly the same shape that we project from what Ibn al-Haytham is describing. So there is, if we take this axis of symmetry here, this curvature is taken to be the same from the anterior part and the posterior part of the crystalline. And yet, if you look at the orthogonals, they should be tending towards the center of the eye, but here at these points, they refract, preserving the ordering of MN in the manner it is without inversion. So we can't talk about the eye here simply as a sort of camera obscura. Once these rays of lights are touching the crystalline, here we are transforming that situation of treating the anterior parts of the transparent coats of the eye as optical instruments to starting now to talk about living organs. It's part of some organism that is sensing. And here it is that physiology of the eye is connected also to the nervous system. And from that point, we consider the circumstances under which there is this unification of the sensation in the last sentient. The last sentient is described more as al-hiss al-mushtarak in the language that has been rendered to the text of Bacon. So the sort of common sense being a hiss mushtarak, what we might attribute more to what happens in the last sentient as a pure sensation that hasn't yet been transformed by the psychological aspects of vision into that which is judged as being a given shape or another, or a given intention or another, hasn't been translated into that which can be recognized as a given entity that I have encountered before, or that I could measure against what I have encountered before by way of my memory, and also the interplay of my memory with imagination. The last sentient is the last organ that has the purity of the sensation, and other faculties that are rooted in the brain engage in the act of judgment. While we see in the case of Bacon, and my suspicion is it's more coming from his reading of the De Anima of Avicenna, that there is a sort of tendency to say that the last sentient itself, as a common sense, is already starting the process of judgment. So this is again a sort of distinction between the two traditions. We have similar images, but at a more intricate kind of rendering, by way of showing more than one ray of light emitted from a given point of a visible object in the dioptrique of Descartes, which, to my mind, looking at it and analyzing the way light behaves within the eye as it is introduced in it, it is still within the older tradition. It's not yet making any kind of addition in knowledge in terms of the optical aspect of studying the structure of the eye and how light behaves within it. And I wanted just to give a very brief highlight concerning, that kind of engagement with the study of the anatomical structure of the eye that is resting on the study of the sphere, and using it also as an anaclastic instrument, as also an optical entity. So it is not here a focus in the studies that we find much more at a very intricate and advanced level in the later parts of the optics of Ibn al-Haytham, when he deals with refraction and reflection, where besides spherical sections, he evokes also conical sections, sections from cylinders. But the study of sphere itself is of importance in the understanding of the way light behaves as it enters into eye, given that the multiple coats, transparent coats of the eye, including the structuring of the crystalline, is dependent on spherical sections. And some of the studies on the properties of the spheres are found in multiple extensive examples in the optics of Ibn al-Haytham, and also in what could be attributed to Bacon, because there's questions over this image that is circulating sometimes as being part of the Opus maius, but it gives a sort of a fine explanation, simplified, of the focusing of light as it falls onto a spherical optical instrument that hypothetically contains something akin to water. It is simplified because it doesn't take into account, for instance, the thickness of the glass that contains the water, the multiple refractions that would happen between three different transparent entities, but it is fine as a sort of diagrammatic explanation of the refraction possibly that happens at this point. Even though when we consider the cases in which Ibn al-Haytham was studying the sphere, he is very much concerned also over aspects that relate to spherical aberration, this kind of fuzziness in the capacities of focus that we have in spherical sections, whether we treat them as refractive or as reflective entities. And the study again of the sphere is of importance, not only in the context of studying direct vision, but also in offering explanations that could be of use for other disciplines such as meteorology. And this is particularly the case with the reception of the optics of Ibn Haytham in the traditions of Theoderic of Freiburg, and also I would say more prominently in this case in the case of the recension of the optics by Kamal Din Farisi, where the study of the rain droplet itself becomes a basis for offering an alternative theory concerning the rainbow, and by consequence an alternative theory concerning the notion of color in Ibn al-Haytham, because color in Ibn al-Haytham has a sort of ontological ambiguity to it, because it is associated with mainly with the lit visible objects, but at certain point he suggests as if it has an existence in and of itself that becomes actualized by illumination. So when the entity is receiving light, so it becomes itself that which emits light, it is emitting accidental secondary light that carries with it the color. So color is always accompanying these secondary light, and propagates in the same way as primary lights, in the sense that it goes in a rectilinear fashion within an isotropic homogeneous transparent medium, and that it refracts as it moves between one transparent medium into another that has a different level of density to it, and that reflects from polished surfaces. So there is a reforming of this theory that we find, for instance, in the tradition of Kamaluddin. Now, there's a beautiful another example that we find in the Opus maius of certain features that we also find in the optics of Ibn al-Haytham and also in the dioptrique of Descartes, which is a classic example of the manner refraction affects the way we see entities, especially if they are submerged, let's say, in water, and we're looking at them from a position where the eyes are in a ambient sort of environment that is like air. When we see them much closer to the surface, and in some kind of vessels, we see them even larger than the scale that they actually have. These are the sort of highlights that I wanted to bring from mainly the parts that related to what we assigned for the reading, but also indicating that for us to grasp the fuller extent, we needed to delve deeper into also in the Opus maius treatment and in other chapters and in other distinctions within part 5 of issues that pertain to refraction of light, because of its vital importance for understanding the processes that underpin direct vision in terms of the way light behaves when it is introduced into eye. And also there is the study of reflection, which is has a technicality to it, but what we don't find in the Opus maius is the same level of extensive engagement with multiple description of diagrams that relate to various properties of the reflection, for instance, of light within let's say, the sphere. We have some of these diagrams, but they are much less intricate than the level we find, for instance, dedicated to them in the optics of Ibn al-Haytham, which take a large chunk of the opus itself. And I think, hopefully Professor Charles Burnett will tell us a bit more about the state of the art now of dealing with the parts of the optics of Ibn al-Haytham that are translated into English, that deal with the catoptrics, the reflection of light, given the great service that has been rendered to the scholarly community beyond also our fields of study in terms of the publication of the English translation of the optics of Ibn Haytham in parts. And thank you.